Hello and welcome to Astronomy Daily, your daily dose of what's happening out there in the cosmos. I'm Anna.
And I'm Avery. It is Thursday, the 12th of March, 2026, and today's show is a packed one.
We've got an interstellar comet that's absolutely loaded with alcohol, a rocket that bounced back from an explosive year to nail its seventh flight, and the biggest NASA briefing in months. The Artemis II Flight Readiness review is happening right now as we record.
We've also got some beautiful science from deep inside the sun, a satellite that came home early thanks to the solar cycle, and a brand new gas cloud discovered swirling around the black hole at the heart of our Milky Way.
Dick stories, let's get into it.
Our first story is one of my favorites in a while because it involves an interstellar comet that's, frankly, a little bit drunk.
You're going to milk that headline all episode, aren't you?
Every chance I get. So, 3I-ATLS. If you've been listening to us over the past several months, you'll remember this is only the third confirmed interstellar object ever detected passing through our solar system. It came from somewhere out there, from a completely different planetary system, and it's been one of the most intensely observed objects in recent memory.
And now astronomers using ALMA, the Atacama Large Millimeter Submillimeter Array in Chile, have published new findings about its chemical makeup. And what they found is genuinely surprising.
Using ALMA's Atacama Compact Array, researchers studied the coma, that glowing halo of gas and dust around the comet's core, as 3I-ATLS was warming up on its approach towards the sun in late 2025. They focused on the fingerprints of two molecules, methanol, which is a type of alcohol, and hydrogen cyanide.
And the results were extraordinary. In most solar system comets, those two molecules show up in roughly comparable amounts. But in 3I-ATLS, the ratio of methanol to hydrogen cyanide was between 70 and 120 to 1. That's not just unusual, it places it among the most methanol-rich comets ever studied, period.
Nathan Roth, the lead researcher from American University, put it really beautifully. He said, observing 3I-ATLS is like taking a fingerprint from another solar system. The details reveal what it's made of, and it's bursting with methanol in a way we just don't usually see in comets from our own solar system.
There's another fascinating detail here, too. In most comets, hydrogen cyanide flows out from the nucleus, the central core. Methanol usually does the same. But in 3I-ATLS, the methanol is coming from two places, the nucleus and from tiny icy grains drifting in the coma around the comet. Those grains are essentially acting like miniature comets of their own, releasing methanol as they warm up in sunlight. It's a level of structural complexity we haven't seen traced in an interstellar object before.
What does all this methanol tell us? It points to a comet that formed in an extremely cold environment, possibly a dark molecular cloud packed with carbon monoxide ice, and that its icy material was incorporated into the comet's nucleus with very little alteration. Essentially, this thing is a chemical time capsule from a distant planetary system, and it's older than our own sun.
And here's a fun watch this space moment. 3I-ATLS is currently about 3.8 astronomical units from the sun, roughly the distance between Mars and Jupiter, and heading outward at around 28 kilometers per second. On March 16th, just 4 days from now, it makes its closest approach to Jupiter, passing within about 0.36 AU. It's one of the last major milestones before this visitor disappears into interstellar space for good.
It's been one of the most scientifically productive interstellar visitors we've ever had the luck to catch. Every observation has taught us something new about how planetary systems, not ours, form and evolve.
Story 2 is a proper comeback story, and those are always fun to tell. Firefly Aerospace successfully launched its Alpha rocket last night, Wednesday the 11th, from Vandenberg Space Force Base in California. And it was a mission called Stairway to 7, Flight 7, and it absolutely nailed it.
For context, Firefly had a rough 2025. Two major mishaps, a failed launch in April and then an explosive ground test in September that destroyed a first stage. The rocket had been grounded for nearly 11 months, so this was a significant moment for them.
The mission lifted off at 5:50 p.m. Pacific time, completed nominal stage separation, achieved orbital insertion, and delivered a demonstrator payload for Lockheed Martin. The second stage engine even performed a relight, a bonus milestone for validating new systems.
And this wasn't just any flight. Spareway to 7 was the last flight of Alpha's Block 1 configuration. Firefly is now transitioning to Block 2, which is an upgraded version of the rocket. Longer, more capable, with a new in-house avionics suite and improved thermal protection. Those systems were tested in shadow mode on this flight and confirmed working.
CEO Jason Kim said the mission was, quote, flawlessly executed. And while Alpha has now had full mission success just 3 times in 7 attempts, the trajectory is clearly improving. And Firefly's lunar landing success with Blue Ghost last year showed they can absolutely get the job done.
The first Block 2 flight will carry a U.S. Space Force mission called Victus Hayes Jackal, scheduled for no earlier than the second quarter of this year. Firefly also has plans to expand Alpha operations to Wallops Island in Virginia and the S-Range Space Center in Sweden. Good times ahead for this team.
All right, story 3, and this one is literally happening as we speak. NASA held its Artemis II Flight Readiness review today, Thursday the 12th, at Kennedy Space Center in Florida, with a press conference at 3 p.m. Eastern featuring NASA Administrator Jared Isaacman.
A flight readiness review is a critical milestone. It's the formal process where all the key mission stakeholders come together and evaluate whether every system, every procedure, and every person is ready to fly. It's one of the last major gates before a launch date gets set.
To recap where we are, Artemis II is the first crewed mission of the Artemis program. 4 astronauts flying around the moon and back inside the Orion spacecraft, farther from Earth than any humans have ever traveled. The crew is Reed Wiseman, Victor Glover, Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen.
The mission hit a snag in late February when a helium flow issue was found in the upper stage of the Space Launch System rocket after a wet dress rehearsal. The stack had to be rolled back into the vehicle assembly building for repairs. NASA has since identified and fixed a seal obstruction in the quick disconnect causing the problem, and technicians have been validating the repairs.
The rocket is currently targeting a second rollout to the launch pad later this month, with an April launch window on the table. We'll have the outcome of today's press conference in our show notes. This story is moving fast, and we'll be covering every step of it as we get closer.
It has been over 50 years since humans flew beyond low Earth orbit. Artemis II is going to change that, and we are so close.
Well, we certainly hope so.
Story 4 is a beautiful piece of long-game science. Researchers from the University of Birmingham and Yale University have published a study in the monthly notices of the Royal Astronomical Society that reveals something fundamental and surprising about our star. The sun's internal structure shifts measurably from one solar cycle to the next.
This might sound like it should be obvious. Of course, the sun changes. But here's the thing. During solar minimum, the sun is supposed to be at its calmest. Fewer sunspots, weaker magnetic fields, a quieter, more uniform surface. The assumption had always been that these quiet periods were basically the same each time around.
And they're not. The team used a network of 6 ground-based telescopes called the Birmingham Solar Oscillations Network, BISON, which has been listening to the sun hum for over 40 years. They analyzed tiny vibrations inside the sun, essentially sound waves trapped inside the star, to infer what was happening beneath the surface. This field is called helioseismology, and it's essentially the same principle as using seismic waves to map the interior of the Earth.
They looked at 4 successive solar minima, the quiet periods between solar cycles 21 and 25, and found that the minimum between cycles 23 and 24, which fell in 2008 to 2009, was structurally different from the other 3. That minimum was already known to be one of the quietest and longest on record, but now they've shown it left a measurable internal fingerprint.
Specifically, a sound wave glitch caused by helium ionization just below the sun's surface was significantly stronger than in the other 3 minima. and the speed of sound in the outer layers was slightly higher, suggesting subtly different gas pressures, temperatures, and magnetic field strengths deep inside the sun.
Why does this matter? Because how the sun behaves during its quiet periods has a strong bearing on how active the next cycle will be. Better understanding solar minima means better space weather forecasting. And space weather affects satellites, GPS, power grids, and communications infrastructure here on Earth.
Professor Bill Chaplin from Birmingham summed it up perfectly. For the first time, they've been able to clearly quantify how the sun's internal structure shifts between one cycle minimum and the next. And the techniques used here could eventually be applied to other sun-like stars using ESA's upcoming Plato mission. The sun isn't just our star, it's our best laboratory for understanding stars everywhere.
Following up on a story we brought you a couple of days ago, you could say Story 5 has a certain poetic quality to it. Yesterday morning, Wednesday the 11th, NASA's Van Allen Probe A re-entered Earth's atmosphere and burned up over the eastern Pacific Ocean, ending a mission that launched back in August 2012, nearly 14 years in space.
The Van Allen probes, there were two of them, A and B, were built to study Earth's radiation belts. Those are the two massive donut-shaped zones of high-energy charged particles trapped by our planet's magnetic field. They're named for physicist James Van Allen, who discovered them in the late 1950s. Understanding these belts is critical because they shield Earth from cosmic radiation and solar wind, but they can also be brutal on satellites and spacecraft passing through them.
The probes were originally designed for a 2-year mission. They ran for nearly 7. During that time, they made a series of landmark discoveries, including the first confirmed observation of a transient third radiation belt, which can form during periods of intense solar activity. The spacecraft ran out of fuel in 2019 and have been drifting in orbit ever since.
Here's what made yesterday's re-entry newsworthy beyond the usual satellite farewell. NASA had originally calculated that Probe A wouldn't re-enter until 2034, 8 years later than it actually did. The culprit? The current solar cycle. We're in a particularly active phase right now, and increased solar activity heats and expands Earth's upper atmosphere, which creates more drag on satellites in low to medium orbit, pulling them down faster than expected.
The 600-kilogram spacecraft mostly burned up on re-entry, as expected, with a 1 in 4,200 chance of any surviving debris causing harm to anyone on the ground. The U.S. Space Force confirmed re-entry at 6:37 a.m. Eastern Time over the Eastern Pacific. No injuries or debris impact reported.
But Probe B is still up there, and its re-entry isn't expected before 2030. Though, given what just happened, we might want to keep an eye on that estimate too. The sun has a way of accelerating things.
And our final story brings us right to the heart of our own galaxy and the supermassive black hole sitting there. Astronomers at the Max Planck Institute for Extraterrestrial Physics have discovered a new gas cloud orbiting Sagittarius A star, the 4 million solar mass black hole at the center of the Milky Way, about 27,000 light years from Earth.
The new cloud is called G2T, and it was found using the IRIS instrument, the Enhanced Resolution Imager and Spectrograph, mounted on the European Southern Observatory's Very Large Telescope in Chile. 2 previous clouds, known as G1 and G2, had been observed orbiting Sagittarius A star for years, but their true nature was still hotly debated. Were they pure gas clouds, or were they hiding stars inside them?
The discovery of G2T turns out to be the key that helps answer that question, because the 3 clouds don't just share the same general neighborhood. Their 3D orbits are almost identical, just rotated slightly with respect to each other.
And here's why that's a big deal. If G1, G2, and G2T each contained a hidden star at their core, you'd expect those stars to have very different orbital histories. The odds of 3 independent stars settling into nearly identical orbits around the supermassive black hole are extraordinarily slim. So the matching orbits strongly rule out the hidden star hypothesis.
Instead, the astronomers believe all 3 clouds likely share a common origin, a massive binary star system called IRS 16SW, which is in that region and is known to be expelling enormous amounts of gas. The three clouds may have been shed from that pair of stars at different times, drifting into similar orbits as they interact with the extreme gravitational environment near Sagittarius A star.
The galactic center is one of the most extreme environments in the universe. Stars and gas clouds hurtling around the black hole at tremendous speeds. And yet, we're still finding brand new objects there after decades of observation. It's a reminder that our own cosmic backyard still holds secrets, extraordinary ones.
That's all 6 stories for today. What a show! A Tipsy interstellar comet, a triumphant rocket comeback, the imminent moon mission update, the sun's inner life, a satellite's fiery farewell, and a new discovery at the very heart of our galaxy.
If you enjoyed today's episode, please subscribe, leave us a review, and share us with someone who loves space. You can find us at astronomydaily.io and on all the major platforms at @AstroDailyPod.
And keep watching the skies. Jupiter's about to get a very unusual close visitor in just 4 days. 3I Atlas, making its last big swing before heading back to the stars.
From Anna and me, thanks for listening to Astronomy Daily. We'll see you tomorrow. In the meantime, keep looking up.
Astronomy Daily. Stories untold. Stories